Welcome back, my fellow programmers. Today on the program, we're going to be starting Unit 4. A whole new world of code opens up for us in Unit 4. We're starting off on 4.1, while loops. We're going to get started with a notional machine. As always, look at the code on the left-hand side, read it through, and try to evaluate what will happen when that code is executed. Starting on line 1, we are declaring and initializing a variable named I, and we are assigning it the value of 0. We see that over here in our stack memory on the right-hand side. We have I in memory with the value of 0. On line 3, we have a new statement, a while statement. We are saying while I is less than 3. So inside those parentheses, we have a Boolean expression. I is currently 0. If we look in our stack memory, we're asking if 0 is less than 3. That Boolean expression will evaluate to true. Since it evaluates to true, we step inside this while loop and we execute line 4, in which we print I to the console. I is 0. We're going to print a 0 to the console. Line 5, we increment I by saying I++. In memory, I is no longer 0, it is now a 1. And now that we are at the end of our while statement on line 6, we go back up to line 3 and we evaluate that Boolean expression again. That Boolean expression, I less than 3. In stack memory, I is currently a 1. We are asking if 1 is less than 3. That evaluates to a true, which means we step inside this while statement. We execute line 4. We print I to the screen. We're printing a 1 to the screen. That's the current value of I. Line 5, we increment I by 1. I is now 2 in memory. And now we are on line 6 at the end of our while loop again. That means we go back up to that Boolean expression, we evaluate it again. This time I is 2, we are asking if 2 is less than 3. That Boolean expression again evaluates to true. Again, we step inside that while loop, we print out I. This time we are printing out a 2 to the screen. On line 5, we are adding 1 to I. In memory, I now becomes a 3. Line 6, end of the loop, step back up to 3, evaluate that Boolean expression again. Now I is 3. We are asking if 3 is less than 3. This is the first time that Boolean expression evaluates out to false. Since it evaluates out to false, that means we are done with this loop. We do not get to go back inside of it again. We will just continue at the end of it. It ends on line 6, so we immediately jump down to line 7 and we print out complete to the screen. So our next topic is taking a closer look at that while statement. Our learning objective represent iterative processes using a while loop. We have a lot of essential knowledge to cover in this topic. If you are in school and you have a math class, sometimes you will get math homework, and the math homework you will be doing similar problems over and over and over again, and you might want somebody else to do that work for you. In order to do that work, they would need to know which problems you want them to work on. And then the algorithm to complete that homework is a very repetitive process. You're going to set the problem to problem number 1, solve the problem, and then add 1 to the problem, so then you're at problem 2. Solve that problem, add 1 to the problem, so you're at problem 3. Solve that problem, add 1 to the problem, so you're at problem 4, and so on and so forth until you solved all your problems. As a programmer, an alert should go off into your head where you see, hey, this is going to be repeated code. And as a programmer, you never want to type the same algorithm in your code multiple times. The reason why is if your algorithm is wrong, you would need to update it in multiple places. We just want to code that algorithm one time and just repeat it as many times as we need. When we first learned to code, we learned how to do sequential statements. We did one line of code after another. Our code executed from the first line all the way down, continuing line by line until it got to the end. Not too long ago, we learned our control flow or our conditional statements in which we could ask a question and then we could have branching logic that would take us one way or another way, and then our path would still join up at the bottom. Now we are going to learn iterative statements where we take our sequential steps, and this time we will ask a question, but that question loops us back up and has us repeat a certain step for a certain amount of times before we continue that downward flow. This aligns with our essential knowledge. Iteration statements change the flow of control by repeating a set of statements 0 or more times until a condition is met. That sound means that we have a new statement. That statement is the while statement. It is an iteration statement that, while true, repeats an algorithm. We have a very simple example of it in the box below. Identifying the parts of it, that first part is the while keyword. Then in parentheses, we have a Boolean expression. It is known as our looping condition, like any Boolean expression that is going to either evaluate to true or to false. And then finally, inside the curlies, we have our algorithm. These are the lines of code that are meant to repeat while the Boolean expression evaluates to true. Here we are presented with two code statements that are almost identical. Besides for line 2 on both of them, line 2 on the left, we have the keyword if. Line 2 on the right, we have the keyword while. Take a second and pause the video and try to determine what will be printed after each section of code is executed. On the left-hand side, we are initializing x to 0. On line 2, we're asking if x is less than 3. We're asking if 0 is less than 3. That evaluates to true. We then print out x and an underscore. So we print out 0 and an underscore from line 3. On line 4, we add 1 to x. So now x becomes a 1. We are done with our if statement. We continue on with line 6, and then we just print done. Looking at the right-hand side, we are again initializing x to 0. This time we're saying while x is less than 3. Well, x is 0. We're asking if 0 is less than 3. That evaluates to true, which means we get to go inside this while statement. We're going to print x and an underscore. X is currently 0, so we print a 0 and an underscore. On line 4, we add 1 to x. X becomes a 1. But since this is a while statement, when we get to the end of it on line 5, we go back up and we then evaluate that Boolean expression again. X less than 3, x is 1. We're asking if 1 is less than 3. That is true. We go inside, we print x and an underscore. X is currently 1, so we print a 1 and an underscore. Line 4, we increment x by 1, x becomes 2. We get to line 5, we go back up to that Boolean expression again. This time x is 2. We're asking if 2 is less than 3. Still evaluates to true. We still get inside the while statement. We're going to print x and an underscore. X is 2. 2 and an underscore. Line 4, we add 1 to x. X becomes 3. Line 5, we go back up and evaluate our Boolean expression again. We are asking if 3 is less than 3. We evaluate to false. Since this evaluates to false, we then continue after the while statement, and then we are going to print done. This aligns with our essential knowledge. In loops, the Boolean expression is evaluated before each iteration of the loop body, including the first. When the expression evaluates to true, the loop body is executed. This continues until the expression evaluates to false, whereupon the iteration ceases. In the box, we have a while statement. We are using this while statement as a loop. Let's just break up the parts of it so we can understand each part. On the first line, we have int I is equal to 0. That is what we are going to call our iterator. An iterator is just a variable that we are going to use as a counter while we iterate through this loop. We need to declare that iterator before the while statement. The iterator needs to be declared before the while statement. On line 2, we have the while keyword. After the while keyword, we have our Boolean expression, or in other words, our looping condition. We're going to loop while I is less than or equal to 10. After that, then we have an algorithm. What series of code do we want to repeat multiple times? And finally, inside of our algorithm, we have an update statement. We need to move that iterator in such a way that our looping condition will eventually evaluate to false. So we must update that iterator in the algorithm. So if we want to use the while statement as a loop, we need to remember to include all of these different parts. Again, we have two sections of code. Each one of these features a while statement. Take a minute to evaluate each one and determine what will be printed to the screen after each section of code is executed. Looking at the while statement on the left, we are setting our iterator variable of I equal to 0. We are looping while I is less than or equal to 10. Every time we loop, we're going to print out the current value of I and an underscore, and we're counting up by 1. So we are going to count from 0 to 10 by ones. So we will print out 0 underscore 1 underscore all the way up through 10 underscore. That will be what's printed because of the while loop. Once we get to 10, that will be the last time we enter the while loop. We'll print the 10 underscore. I will increment to an 11, and then 11 is no longer less than or equal to 10. That's the first time that Boolean expression will evaluate to false, and then we will print done. The box on the right is very similar, except that we have an if statement on line 3. You should be able to recognize that algorithm of that if statement. If I mod 2 equal to 0, that's asking if a number is even. So we are only going to print out numbers if the number is even. We're still going to start counting at 0. We're still going to count while I is less than or equal to 10. We're still going to count up by 1, so we are still going to count from 0 to 10 by 1, but we're only going to print every time I is even. So now we're just going to print out 0, 2, 4, 6, 8, 10, and then we'll print that final done the first time I is less than 10 evaluates to false, and we step outside of that while statement. On the left-hand side of the screen is that same block of code that we just saw previously, where we just printed out even numbers. Here is another while statement. Now looking at this while statement, our iterator variable of I is starting at 0. We are still looping while I is less than or equal to 10. We are still printing out I. This time we're printing out I every single time. There's no if statement around this. And on line 4, our update statement, we are not adding 1 to I every time. We're adding 2 to I every time. So we're counting by 2s. So if we start at 0 and we count by 2s, and we're going to count while I is less than or equal to 10, well, then we're going to print out those even numbers again. The algorithm on the left and the algorithm on the right perform the same task. They just look a little bit different. The one on the right is just counting up by 2s instead of counting up by 1s. We don't need to update by 1 every single time. We can update by 2s, by 3s. We can update by using a times in there as well. On the left-hand side of the screen is code that we've seen before. This is the while statement that counts from 0 to 10, counting up by 1s. On the right-hand side of the screen, we have a different block of code. Go ahead and evaluate that block of code to determine what will be printed to the screen. On line 1, we have our iterator variable. We named it x. That's fine. It doesn't need to be I. We can name our iterator variable whatever we want. This time we are initializing it to the value of 10. We're looping while x is greater than or equal to 0. We're going to print out x and an underscore. And this time we are subtracting 1 from x every time. So x is starting at 10, but we're counting down by 1 every time. And we're going to keep doing that while x is greater than or equal to 0. This time we're going to print out the numbers from 10 to 0, and then we're going to print done. So 10 is the first number that prints. We subtract 1, then 9, then 8, then 7, all the way down to 0 would be the last number that we print. We would subtract 1 from it. It would become -1. -1 is no longer greater than or equal to 0. That's the first time our Boolean expression evaluates to false. So then we end our while loop and we print done. Here we have two loops. We don't want to know what's going to be printed. We just want to know how many times each loop will iterate. So how many times will they repeat? Take a look at both of them and try to determine how many times each while loop will iterate. Starting with the left, we have an iterator of I. We are initializing that to 100. We're going to loop while I is greater than or equal to 10. Well, I is 100. We're asking if 100 is greater than or equal to 10. That's true. We're going to print something, and then we're going to increment I. I would be 101. We're going to ask if that's greater than or equal to 10. That's going to be true, and then we're going to just keep adding to I. I is just going to keep getting bigger and bigger and bigger and bigger. It's always going to be greater than 10. This loop is going to have infinite iterations. So we just made a loop that loops forever. On the right-hand side, we are initializing I to 100. We are looping while I is less than or equal to 10. We're asking if 100 is less than or equal to 10, which evaluates to false. And so we just skipped the entire while statement, and this one iterated 0 times. This aligns with our essential knowledge. A loop is an infinite loop when the Boolean expression always evaluates to true. Also, if the Boolean expression evaluates to false initially, the loop body is not executed at all. Here we have a method called addUp. It has a return type of int, and it accepts an int called num. We want to know what will happen when we call addUp and we pass in the actual parameter of 4. So num is 4. We're creating a sum and we're setting that equal to 0. We are creating an iterator variable named I and setting that to 0 as well. And we're looping while I is less than num. While 0 is less than 4, we're going to add I into a sum and increment I. So then I will become 1, 1 less than 4, add 1 into the sum. I is 2, 2 is less than 4, add 2 into the sum. Increment I becomes 3, 3 is less than 4, add 3 into the sum. And then finally, I is 4, 4 is no longer less than 4. And then we return the sum. So this will return the number 6, which is that 0 plus the 1 plus the 2 plus the 3. On the right-hand side, we have a similar method with just one change. Lines 7 and 8 are swapped. Same question, what will the method call addUp4 evaluate to? This time, if we pass in a 4 for num, we're still going to set our sum to 0. We are still setting our iterator variable to 0. The first time our while loop executes, we're asking if 0 is less than 4. That's true. We're going to add 0 into the sum. So our sum is still 0. 0 plus 0 is 0. We're adding 1 to I becomes 1. And then we return the sum. At this point, the sum is 0. We return 0, and we do not continue the loop. Whenever you hit a return statement in a method, you leave. It doesn't matter if you're in an if statement. It doesn't matter if you're in sequential code. It doesn't matter if you're in a loop. Whenever a method hits a return statement, that method is done. We do not continue. So if you ever return inside of a while statement, then you will not finish running that while statement. This aligns with our essential knowledge. Executing a return statement inside an iteration statement will halt the loop and exit the method or constructor. Another while statement on the left, we want to know how many times this loop will iterate. Go ahead and run through it and just find out how many times will that loop. That block will iterate 4 times when W is 5, when W is 10, when W is 15, and when W is 20. Here's another while statement on the right. Go ahead and read that code and determine how many times that while loop will iterate. That statement on the right, we have no idea how many times that loop will iterate. We know that it will iterate at least one time. We're initializing is fun to false, and we're saying while not is fun. So if is fun is false, not false is true. So we will get in here one time. We're going to ask the user, is this fun? And then we're going to get the user's response. As long as the user keeps entering false, they will be stuck in this loop over and over and over again. The only way for the user to get out of this loop is to admit that they are having fun. We don't know how many times that will take. Some users might be having fun from the beginning. Some users, it might take seeing this question 100 times before they answer is fun is true. So on the right is what we see as the more common application of the while statements. While statements are primarily used when you don't know how many times you are going to iterate. We see occurrences like this in programs like while is playing. So if you made a tic-tac-toe game, if they played one time, and you can ask them if they want to play again. And while they still want to play, you will continue doing that loop over and over again. While they still have lives, the game would still be playing. While their health is greater than 0, while the user is still logged in, you will show them their picture or their activity feed or whatever. While their password doesn't equal what they entered, you'll let them try to enter their password again. While not is redundant. So all of these, we don't really know how many times each one of these will loop. We are going to see some practical applications of using iteration. One of them is going to be a prime number algorithm. We have the same learning objective, represent iterative processes using a while loop. So, when is Amazon Prime Day? Well, actually, Amazon Prime Day is not a single day. It is actually 2 days. It's July 11th and July 12th. If we look at July 11th, the 11 is actually a prime number. Amazon Prime Day actually occurs on a prime day. July 12th, 12 is not a prime number. That is a composite number. So the second day of Prime Day occurs on a composite day. The question, though, is how do we know that 11 is a prime number and 12 is not a prime number? We want to write the steps to determine if a number, any number n, is a prime number. Go ahead and pause for a second and write down those steps of if I gave you a number n, how could you prove that n is a prime number or not? Your steps might look something like this. You're going to get that number n. You're going to divide n by every number from 2 up to but not including n. If any of those numbers divide evenly into n, then n is not a prime number. If you get through the whole list, none of them divided in evenly, then n is a prime number. This aligns with our essential knowledge. There are standard algorithms to identify if an integer is or is not evenly divisible by another integer. What this would look like in practice if we were given an n of 11. So step 1, we got our n, that's 11. Step 2, we're going to divide n by every number from 2 up to but not including n. So we're going to start off by seeing if 11 is evenly divisible by 2, and it is not. So we have to continue, and we're going to see if 11 is evenly divisible by 3, and it's not. And we keep on continuing until it evenly divides, or we get up to the number n minus 1. And since we checked every number from 2 up to n minus 1 and none of them divided in evenly, then we can definitively say that 11 is a prime number. Now, technically, we don't really need to go up to n minus 1. Technically, we really only need to go up to the square root of n, but that's a math concept for a different class. For simplicity's sake, we're just going to say up to n minus 1. This time, if n was 12, we're going to do the same thing. We're going to divide n by every number from 2 up to, but not including n. If any of them evenly divide into n, then n is not a prime number. So the first thing we're going to do, we're going to say 12 divided by 2. Well, that divided in evenly. We got a 6. We don't need to test anything else. We can say that n is definitely not a prime number in this case. Now that we have that algorithm, what we want to do is we want to turn that into pseudocode. Pseudocode is just a written description of code. It's not necessarily written in any programming language. It's just a way for you to structure what your lines of code would be without having to worry about the syntax and having all of your parentheses and curlies and semicolons. It helps you work out the algorithm before worrying about how to write it in a programming language. You still break it down by which line of code will do what, but you just don't have to be so hung up about the structure. Since you have never written pseudocode before, I'm going to start off and just give you this one. We have our method called isPrime. It's going to accept a parameter that we will call n, and it's going to return a Boolean. It's going to return true if n is prime. It's going to return false if n is not prime. The first thing that we are going to do inside of our algorithm is we are going to create an iterator variable called I, and we're going to set that to 2 because we want to start dividing by 2. We're going to loop while I is less than n because we want to go up to but not include n. So looping while we are less than n will cover that. And then if I ever evenly divides into n, then we can return false because this is not a prime number. If we get through the whole list, so after the while loop, we checked every single divisor, then if we're still hanging around, that means we never returned false. That must mean that what we have is a prime number. Now that we have this pseudocode, we should be able to easily take this pseudocode to the computer and then write this method. Here we have some algorithm tips that will apply to a lot of these algorithms that we are going to write with loops, not necessarily all of them, but we have to determine when can I return a value inside of a loop and when do I have to wait to return a value after the loop. We have a template that we can use to help us to determine if we can return a value inside of a loop. You just need to complete these statements. I only need one example to prove. In our case, I only need one example to prove n is not a prime number. And that's when any number evenly divides into n. I just need one example. As soon as I hit that first example, that's it. I'm done. That's when we can return inside of a loop, when we only need one example to prove something. If we look down at our prime number algorithm at the bottom, we see that if statement inside the while. I'm just looking for that one example that will let me get out of here early. I'm just looking for that one example that where any number evenly divides into n. I don't care if it's the first one, the second one, the third one. I don't care if it's the last one. I just need one example only. When do I have to wait to return a value after a loop? Again, we have a template. We just need to complete the sentence. I need to check every example to prove. In our case, we need to check every example to prove n is a prime number. We cannot determine that until we checked every example. Until we tried to divide by everything, we cannot be sure that n is a prime number. Whenever we need to check every example, we need to wait to prove, we need to wait to return after the while loop. And so our case, this is when no number evenly divides into n. I've checked every single number and none of them divided in evenly. Our next algorithm is to identify the digits in a number. Same learning objective, represent iterative processes using a while loop. Here we see a number 312. Programmatically speaking, which number is the easiest to isolate? So in code, is it easiest to get the 3, the 1, or the 2? Well, the easiest number to get is the 2, because if we mod this number by 10, that calculation will give us the 2. Programmatically speaking, which number is easiest to eliminate? Is it the 3, the 1, or the 2? In this case, the easiest number to eliminate, again, is the 2, because if I take 312 and I divide it by 10, integer division tells me that the answer is going to be 31, and I eliminated the 2 at the end. Keeping that in mind, we can then easily get every single digit from a number. We do that by performing modulo division and integer division. Starting with the number 312, when we mod it by 10, that's going to give us the 2. That's going to give us the digit in the ones place. Now that we have that digit, we can get rid of it by taking 312 and dividing it by 10. Integer division tells us that that's 31. And now we just removed that digit. Continuing on, we have 31. We're going to mod that by 10. That's going to give us the digit in the ones place, which is a 1. Now that we got that digit, we can get rid of it by taking 31 divided by 10. That's going to give us 3. Now we're left with the 3. We want to get the digit in the ones place. 3 mod 10 will give us that digit in the ones place, the 3. Now we need to get rid of the 3. So 3 divided by 10 for integer division, that's going to give us a 0, and we have no more significant figures left in our number. We turned it into a 0. So using those ideas, we can write an algorithm to calculate the sum of the digits in a number. So again, if we had the number 312, what we want to do is we want to then calculate 3 plus 1 plus 2. We want to get the answer of 6. And we're going to do this by a series of getting the digit in the ones place and then removing the digit from the ones place. So go ahead and pause for a minute and write those steps to calculate the sum of the digits of a number. The steps are going to be that we want to set a sum variable to 0. If we want to calculate a sum, the first thing that we're going to create is a sum variable and set it to 0. If we have a number n, we want to mod n by 10 to get the digits in the ones place. We're going to add that digit into the sum. And then we're going to use integer division on m to remove the digit in the ones place. And we're going to repeat steps 2 through 4 until we popped off every single digit and n is 0. This aligns with our essential knowledge. There are standard algorithms to identify the individual digits in a number. Now that we have those steps, take a minute, pause the video, and write those steps out as pseudocode. Our pseudocode would look as follows. We have a method called SumDigits where we get a parameter n. We're going to return an integer, which will be the sum of those digits. Since we want to calculate a sum, the first thing we're going to do is set sum to 0. We're going to loop while n still has digits, while there are still digits to pop off, meaning we haven't turned it into a 0 yet. We're going to get that digit in the ones place and add it to the sum, and then we're going to remove the digit from the ones place. And then we're going to do that for every single number, and then after the while loop, then we can return the sum. We cannot return inside the loop here. We need to wait until we popped off every single number and added it into the sum. Another algorithm, the count frequency algorithm, same learning objective, represent iterative processes using a while loop. How do you make a word an adverb? Well, that's easy. You just slap an ly at the end of it, and then you can turn any word into an adverb. All right, that's not how English works, but I'm not trying to teach you English. I'm trying to teach you computer science. So for our sake, let's just pretend that any word with an ly is an adverb. So we want to count how many words are likely to be adverbs, how many words end in ly. Looking at our list of 10 words, how we would do it, we would first look at the first word. We would see if it ended in ly. If it did, we would count it. Then we would look at the second word, which doesn't end in ly. The third word does end in ly. 4 doesn't, 5 doesn't, 6 doesn't, 7 does, 8 doesn't, 9 doesn't, and 10 doesn't. So we have 3 words that are likely adverbs, and then we could say 3. But we had to go through the entire list to do this. We couldn't just stop at 5 because at 5 we only knew that 2 of the words were likely adverbs. In this case, we cannot return in the loop. The only way that we can be sure that we have the final count is if we went through the entire list. Can we return the count after the loop? Yes, we have to return the count after the loop. We have to look at each word to be sure that we have the final count. Go ahead and write the steps to count the number of words in a list likely to be adverbs. Here are those steps. Since we want to count, the first thing we're going to do is declare a count and set it to 0. We're going to get the next word from the list. We're going to get the last 2 letters from the word. If the last 2 letters are ly, we're going to add 1 to the count. We're going to repeat steps 2 through 4 until we're done with the list. This aligns with our essential knowledge. There are standard algorithms to determine the frequency with which a specific criterion is met. Go ahead and take a minute and turn your steps into pseudocode. Here is our pseudocode. Our method is called count adverbs. We're going to be given a list and we're going to return an int, which is going to be the count of words in there that are likely to be adverbs. We're going to start off by setting our count to 0. While the list still has words in it, we're going to set word to the next word in the list. We're going to set end to the last 2 letters in word. If end is ly, we're going to add 1 to the count. After we go through the entire list, then we can return that count. Another common algorithm, determine a min or max value. Our learning objective, represent iterative processes using a while loop. Given a list of numbers, how do you determine the largest number in the list? Well, we have to keep track of what we think is the biggest number. The best way to do this is just to assume that the first number is the biggest number. So on our list, we are going to write down the first number from our list, which is 21. We're going to assume that's the biggest, and then we'll check every single number to see if we were wrong. So we move down to the second item in the list, that's 32. Whoops, that one's bigger. I'm going to now remember that as the biggest number. I need to continue checking the entire list to make sure that I have the biggest number. Go to the next number. 12 is now bigger than 32, so far I'm still right. Go to the next number. Whoops, 34 is bigger than 32. I'm now going to remember 34 is the biggest number. Go to the next number, 30. And now I'm at the end of the list. Now I can confidently say the biggest number in the list is 34 because I checked every single number. Go ahead and write down the steps to determine the biggest number in a list. Your steps might look something similar to, you're going to set max to the first number in the list. Then you're going to get the next number from the list. If number is greater than max, well, then we need to remember that number now. So then we're going to set max to that number. And we're going to repeat steps 2 to 3 until we're done with the list. Now we can easily change this to determine the smallest number as well. This aligns with our essential knowledge. There are standard algorithms to determine a minimum or maximum value. Pause the video, turn your algorithm into pseudocode. Here we go. We have our get max method in which we accept a list. We're going to return an int. Since we're going to return an int, we need to start off by setting max to some value. We are going to set it to the first number in the list. While the list still has numbers in it, we're going to set num to the next number in the list. If num is greater than max, then we're going to set max to that number. Once we look through the entire list, then we can return the max. Yet another algorithm, this one to calculate the sum and average. Learning objective, represent iterative processes using a while loop. Our question is then, how do you calculate an average? In this case, we mean the statistical mean. To calculate an average, we need to add up every single number in the list. We cannot calculate the average until we've gone through the entire list. Then we divide by the number of numbers in the list. Go ahead and write your steps to calculate the average from a list of numbers. We're going to set our sum to 0 because we need to add up all of the numbers. We also need to remember the count of how many numbers are in the list, so we're going to set our count to 0 as well. We're going to get the next number from the list. We're going to add the number to the sum, and we're going to add 1 to the count so we can keep track of how many numbers we have. We're going to repeat steps 3 through 5 until we're done with the list, and then we can calculate the average. This aligns with our essential knowledge. There are standard algorithms to compute a sum, average, or mode. Pause the video, turn your algorithm into pseudocode. We have our get max method. We are going to accept a list of numbers. We're going to return an integer, which will be the biggest number from the list. We need to keep track of two things, the sum as we go through, and we need to count how many numbers are in the loop. We need both of these to calculate the average. While the list still has numbers, we're going to add the current number to the sum, and then we're going to add 1 to the count. After we go through the whole list, we're going to set the average equal to the sum divided by the count, and then we can return the average. That brings us to the end of this lesson. Make sure that you rate how you feel on those learning objectives. Read over your recap statements. Make sure that you hit me up with any questions or concerns that you have regarding this concept. Join us in our next video and keep programming.